Hello, we're here to talk to you about our semester-long research in semi-supervised domain shift using BERT. Our group consists of me, Robert Doherty, Abdallah Dar, and Ramsey Malouf. So the goal of our project is to build on existing research in semi-supervised domain shifts, primarily using state-of-the-art models such as BERT. So to test performance and sentiment classification of BERT, we're going to fine tune on in-domain labeled data with self-training and tri-training methods and use that on out-of-domain unlabeled data. So the data consists of 4 Amazon review categories: books, DVDs, electronics, and kitchens. For each category, there are 1,000 positive reviews and 1,000 negative reviews, and the rest are going to be unlabeled. So the general methodology is here. We're going to read in the raw text strings, tokenize the data, and then fine tune our pre-trained BERT model to generate BERT encodings, which will be then passed through a linear layer and then convert it into a 0-1 corresponding with positive and negative sentiment.
So the semi-supervised learning methods that we use, the first of them is self-training. And the general algorithm for self-training is that you first train the BERT model on the source domain's labeled data. You then predict the labels on the target domain, which has unlabeled data. Using the predictions that you get, you check if their probability is greater than some threshold. And if so, you choose them and you add them to your labeled data set, almost giving them pseudo labels. So then you retrain your BERT model with labeled data and the pseudo labels on the unlabeled data, hoping it incorporates some of the new things that it learns. The second semi-supervised training method that we look for and explore is tri-training. Tri-training starts with labeled data set of the source domain. We bootstrap the sample into 3 separate samples and they're labeled. We then get 3 different models that are fine-tuned on each of those samples. In short, we have model 1, model 2, model 3, all of these are BERT trained models. Then we predict the labels of unlabeled data set of the target domains, and we get outputs for each of these models. After we get the output of each of these models, we look at the output from the other 2 models and see if they agree. If they do agree, that sample is added to the label sample of the model that you're testing it on with the pseudo label, which is being predicted by the other 2 models. So now we have the label sample that we originally had and new pseudo label samples that is then used to train each of these 3 models. Now, this keeps on going until each of the model converges. And as soon as it converges, we just use a majority vote over the 3 models to choose the labels for each of the unlabeled observation. Now, a natural extension of this is you might think that we might keep reusing unlabeled data with the same labels that was easy for our model to predict. And that's where tri-training with disagreement comes in. What tri-training with disagreement does is it not only checks if the other 2 models agree on some output, it also makes sure that your current model is disagreeing with them. That is giving the opposite model or the opposite output for what the other 2 were saying. And if that's satisfied, then it's added to the label samples with the pseudo labels. And that's the difference between the 2.
So with that said, here was our overall framework for this project. First, we're doing some supervised training where we train BERT on the labeled data of the source domain. We then do either self-training or tri-training on this using this unlabeled target domain. And finally, we test the model on the labeled target domain. And so our baseline for this project involved skipping the middle step over here and really just training the BERT on the labeled data and then testing. So this was our baseline, which we used to later compare the results for self-training and tri-training. Since our data set was balanced, we found it reasonable to use classification accuracies. And you can see here for any pair of source and target categories, the corresponding classification accuracy. The interesting thing to note here is that BERT in this case did outperform BILSTMs, which were used in the reference paper. So far, in looking at our results with self-training, self-training outperforms this baseline in every single category or group of categories. Tri-training is currently a work in progress, and we expect it to also outperform self-training, in alignment with the reference paper. And so in conclusion, we found that the newly developed BERT consistently outperforms the BIAL-STM method in the reference paper. The second main point is that the results from the semi-supervised training methods outperform the baseline supervised training in line with the reference paper. Thank you so much.